The purpose of this video is to help you work through the linear functions quiz that we took last week. Most of you did really well on it, so I didn't want to take the class time to go over it. But I do want to give everybody that didn't do so well on it or had problems with one or two questions a chance to get those questions answered. It's going to be a long video because I'm going to do all 6 problems. If you only need problem 3, just fast forward to problem 3. I'm going to start with question number 1. So we're solving an equation here, and the first thing I notice is that I've got these fractions. I don't want to deal with those fractions, so what I'm going to do is I'm going to go in and I am going to multiply by the same thing on both sides in order to get rid of those fractions. And what I look at to determine is our denominator. So we've got a 3 and a 2. Our common denominator from that would be a 6. So I'm going to multiply both sides by 6. When I do that, here, this is going to be 6 over 1. I'm going to have 6 times 4 is 24, over 1 times 3 is 3. So negative 24 over 3 is going to give me negative 8. And then 9 times 9 minus 2x. And then on this side, I'm going to get 6 over 2, which is just 3. So I'm not too worried about this 3 that's in the denominator here, because when I distribute my 3 here, that will disappear. So I'm going to distribute my negative 8. And at the same time, I'm going to distribute my 3. So when I distribute my negative 8, I'm going to get negative 72 plus 16x equals, and I get 3 times a third is 1, so x plus 3. And then I'm going to get my x's together. So I'm going to subtract x from both sides. And at the same time, I'm going to go ahead and add 72 to both sides. So I get 15x equals 75. Dividing both sides by 15. I get x equals 5. And that's my answer. Pause and rewatch if you need to. I'm going to move on to question 2. So we're solving again here, and we are then going to graph because I have an inequality here. So one of the mistakes that I saw you guys do, those of you that made a mistake, one of the things I saw you do is do this subtraction. That's a no-no. I have to distribute first because distribution is multiplication, and multiplication comes before addition and subtraction. So I'm going to start with the distributing because it's really my only good choice. I guess I could subtract 5 from both sides, but I'm going to go ahead and distribute. So negative 4 times 2x is negative 8x. Negative 4 times negative 7 is a positive 28. And then I'm going to go ahead and combine my like terms. So negative 8x, 28 plus 5 is going to give me 33. And then I've got a 2-step inequality here, so I'm going to subtract my 33. Getting negative 8x is less than, signs are the same, so I add and keep the sign. And dividing by negative 8. Pen doesn't want to work for me today. So I'm going to get x is greater than negative 9. Right there, bells and whistles should have gone off in your head. I divided by a negative, so I need to change my inequality. Remember, I only do that when I multiply or divide by a negative. So my answer here is x is greater than negative 9. Now, if I were asked to write it in interval notation, that would be negative 9 to infinity, like that. That's our interval notation. Graphing on the number line, remember this is going to be an open dot on the 9 because it does not have the or equal to, and it's greater than, so it's shaded to the right. Again, pause if you need to. I'm going to move on to number 3. All right, we have this graph. First, is it a function? The answer there is absolutely not, because it fails the vertical line test. So this is no. Those x values all get reused. For the domain, I'm going to look left to right. And remember I said it's a little hard to see, but we're going to just assume that that's right at 3. Let me make that thinner. Let me try that again. Let me try that again. So it's going to be right there at -3 and this way. So if I look at my x-axis there, that's telling me x is less than 3. So one way to write it is x is less than 3. Less than or equal to. The interval notation would be -infinity to 3 with a bracket. So a lot of you flipped that and you did this. You did 3 to -infinity. The negative infinity has to come first. The negative infinity has to come first. In interval notation, it has to go in the order, smallest to largest. And then my range, I go top to bottom. I've got an arrow at the top. I've got an arrow at the bottom. That means it goes forever. So you can either say all real numbers, or you could have said -infinity to infinity, whichever makes you happy. All right, number 4. Standard form and slope-intercept form. So I'm not in either here. So I'm going to start by getting it into standard form. So I'm going to take my 1/8 y plus 1 equals -3/4 x, and I'm going to get it into standard form. So I'm going to start by adding the 3/4 x to both sides, just to get the x and y together. And at the same time, I'm going to go ahead and subtract 1 to get the constant on the other side. These aren't like terms, so I'm just going to write them. 3/4 x plus 1/8 y equals -1. So all I did so far was get them x and y on one side, constants on the other. Now remember, we have 3 criteria for standard form. X and y on one side, constant on the other. Your a, b, and c, the number, the coefficient of your x, the coefficient of your y, and the constant have to be integers. So right now the fractions are messing us up. And your leading coefficient has to be positive. Greater than 1 is what we say, but since it has to be an integer, it has to be positive. Greater than or equal to 1. All right, so I now need to get rid of my fractions. So I'm going to come in, I'm going to look at my denominators, 4 and 8. The GCF of that is 8. I'm sorry, not the GCF. The least common multiple is 8. So I'm going to multiply everything by 8. So 3 times 8 is 24 over 4 is 6x. For this one, 8 times 1 over 8 is 1, so plus 1y. And then -1 times 8 is -8. Right there, that's the other mistake I saw. We forgot to multiply that one. So this is your standard form. That's your standard form. Your slope-intercept form, you're solved for y. So I could solve from here, but it's actually probably easier to solve from standard form. Try that again. So 6x plus y equals -8, because from standard form all I have to do is subtract my 6x. Worked out nicely. And that's my slope-intercept form. Again, pause if you need to, rewind and rewatch. I'm going to move on to number whatever's next, 5. This one's graphing. I'm in slope-intercept form. So my slope is 1/2. That means up 1 and to the right 2, or I can go down 1 and to the left 2. And my y-intercept is -3. So I'm going to plot my y-intercept at -3. And I'm going to count my slope. Up 1 and to the right 2. So again, all I'm doing there, I am going, oops, I don't want to grab it all. Okay, I am going up 1 into the right 2. That's what I'm doing there. Or I can go down 1 into the left 2. So, or I can go down 1 into the left 2. Down 1 into the left 2. Connecting and extending through. That's my line. Okay, my last problem. So this one's in standard form, so I either need to solve for y or I need to find my intercepts. I'm going to find my intercepts and I'm going to use it doing my cover-up method. So first I'm going to let x equal 0. So I am going to cover up the x because when I let x equal 0, that makes x disappear. So then I solve what's left. 9y equals 36. Dividing both sides by 9, I get y equals 4. Then I let y equal 0. When I let y equal 0, I cover up my x. I cover up my y, and I solve for x. So it's 36 over 15. I'm going to reduce it. 3 goes into both, so 3 goes into 36 12 times. 3 goes into 15 5 times. So 12 over 5. I don't care that it's a fraction. I'm just going to do a little guess. If you want to be more precise, then solve for y and use your slope-intercept form. That will get you more precise. So my y-intercept, 0, 4, 1, 2, 3, 4. Make sure you put it on your y-axis. And then 12/5 is 2 and 2/5. So it's almost 2.5. And then I'm going to connect and extend through. So that is it for the quiz. Again, you can pause, you can rewind, you can rework, but definitely spend time trying to do the problems you got wrong the first time. Try to do them a second time on your own. I hope the video helped.